Sometimes it's hard to believe that we've already witnessed 7 Starship launches. Just a decade ago, the concept of a fully reusable spacecraft of this size was met with widespread skepticism. Many doubted whether such a massive rocket could even leave the ground. Yet here we are. SpaceX has not only proven those doubters wrong, but has successfully launched this gigantic rocket 7 times. The 7th flight was a mix of major wins and notable challenges. According to Musk, the mission achieved about 60% of its planned objectives. For such an early-stage test, 60% is a solid success, though many of us were hoping for an even better performance. Musk also shared crucial details about the flight and the lessons learned afterward, which we'll discuss in this video. Before we dive deeper into the details of this incredible mission and its implications for the future of space exploration, don't forget to subscribe to our channel. Stay tuned for more updates on Starship and SpaceX's groundbreaking achievements. While the Flight 7 included challenges, such as the upper stage exploding during re-entry, it also had significant successes, including the successful recovery of the Super Heavy booster. This booster catch is a critical achievement for SpaceX as it moves closer to making reusable rockets a reality. The upper stage, known as Starship, encountered technical issues during the flight. Problems with the heat shield tiles and flap system led to the stage's failure to survive re-entry. Despite this, the mission still achieved about 60% of its objectives, according to Musk. These included successful tests of key systems such as engine thrust, forward flap operation, and tile adherence during ascent. Musk emphasized the success of the booster recovery as a key highlight of the mission. Recovering the Super Heavy booster is a highly complex process. The booster re-entered Earth's atmosphere at a speed more than twice that of a bullet, requiring advanced engineering to withstand the extreme heat and forces. After re-entry, the booster used grid fins to stabilize and guide its descent back to the launch site. Precision engine burns helped slow it down and align it with the Mechazilla Tower, where robotic arms, nicknamed Chopsticks, were waiting to catch it. The Mechazilla Tower played a key role in the booster's recovery. Its arms executed a carefully coordinated sequence to grab and secure the booster mid-air. This method eliminates the need for ocean splashdowns and transport back to the launch site, saving time and reducing costs. Musk compared the process of catching the booster to catching a fly with chopsticks to highlight the extreme precision required. Beyond catching the booster, SpaceX is improving the efficiency of its post-flight operations. During Flight 7, the booster was returned to its launch mount just 2 hours and 14 minutes after landing. This is a significant improvement compared to Flight 5, where the same process took over 6 hours. These faster turnaround times are essential for SpaceX's goal of increasing launch frequency. SpaceX uses an iterative design process to make continuous improvements. For instance, during Flight 5, a small fire occurred on the booster after landing. By Flight 7, this issue had been resolved, resulting in a smoother recovery. This approach allows SpaceX to identify problems, implement solutions, and refine its technology quickly. Now, the aftermath inspections revealed some very serious issues with both the upper stage and the booster during SpaceX's Flight 7 mission. One of the most significant issues was with the upper stage's heat shield tiles. During re-entry, some tiles either dislodged or failed to perform adequately under the extreme heat generated by atmospheric friction, which can exceed 1,500 degrees Celsius. This failure was catastrophic, leading to the destruction of the upper stage. SpaceX has identified this as a priority area, with plans to improve the attachment mechanisms for the tiles to ensure they remain secure throughout the mission. Engineers are also exploring new materials and bonding techniques to enhance their durability and resistance to vibrations during ascent and the stresses of re-entry. Another problem identified was with the forward and aft flaps of the upper stage. These flaps are essential for controlling the vehicle's orientation and stability during re-entry. Flight data showed that the flaps did not function optimally, likely contributing to the upper stage's inability to achieve a controlled descent. SpaceX is working to reinforce the flap system to ensure it can handle the extreme forces and temperatures experienced during re-entry. The upper stage's Raptor engines also faced challenges. A fuel leak was detected, which impacted the engine's performance during critical phases of the mission. This leak affected the pressure systems required for stable combustion, reducing the overall efficiency of the engines. The booster, while successfully caught by the Mechazilla tower, also had its own set of issues. A small fire was observed on the surface of the booster after landing. Although the fire did not cause significant damage, it raised concerns about residual fuel or debris near sensitive components. This is not the first time such an issue has occurred, indicating a recurring risk. Post-launch inspections also revealed that vibrations during ascent may have weakened or dislodged some of the heat shield tiles. These vibrations, caused by aerodynamic forces, can compromise the integrity of the heat shield even before re-entry begins. NASA has recognized the importance of Starship advancements. Following Flight 7's success, NASA Administrator Bill Nelson congratulated SpaceX and noted how these developments could impact the Artemis program, which aims to return humans to the Moon and establish a long-term presence there. SpaceX's ambitions for Starship extend far beyond supporting NASA. The company aims to make Starship the most reliable and frequently launched rocket system in the world, even surpassing the Falcon 9. In 2024 alone, SpaceX completed an unprecedented number of Falcon 9 launches, exceeding 90 missions by the end of the year. They have already achieved over 400 successful booster landings, with some boosters reused up to 25 times. Musk has stated that SpaceX's ultimate goal is to make Starship capable of conducting 1,000 launches per year. In the short term, Musk has suggested that SpaceX aims to conduct at least one Starship launch per month by the end of 2025. What's interesting about Starship's recent Flight 7 is that Blue Origin's New Glenn also launched on the same day, just hours before SpaceX's mission. The timing of these launches has sparked speculation in the aerospace community, with some suggesting that Blue Origin intentionally delayed the launch of New Glenn to align it with Starship's schedule to send a message. Regardless of intent, the New Glenn launch turned out to be a significant step forward for Blue Origin, with the mission exceeding expectations. New Glenn's maiden flight demonstrated a smooth liftoff and successful stage separation. The rocket's massive first stage, powered by 7 BE-4 engines, delivered consistent performance during ascent. This was a critical test for the BE-4 engines, which Blue Origin has been developing for both New Glenn and United Launch Alliance's Vulcan rocket. Despite the successful orbital insertion, the mission faced a setback when the reusable first-stage booster failed to land on the recovery vessel in the Atlantic Ocean and was lost. The New Glenn booster is equipped with landing legs and guidance systems designed to bring it back to Earth safely, just like Falcon 9 boosters. But they failed to recover at this time. Blue Origin CEO Dave Limp acknowledged the ambitious nature of landing the booster and expressed pride in reaching orbit on the first attempt, stating that further recovery attempts are planned for the spring. That's all for today's update. Thanks for watching, and we look forward to seeing you in the next one.